Picture a 63-year-old man walking into the gym for the 400th time this year. He grabs the same dumbbells he grabbed 2 years ago. He does the same sets, the same reps, the same careful form his physical therapist taught him, and yet the mirror shows almost nothing. The muscle he is chasing simply refuses to show up, and he starts wondering if his body quietly decided that growth was over, that 60 was some kind of finish line nobody told him about. But the truth sitting inside his muscle tissue right now is far more interesting than that, because his muscles are not broken. They are simply not receiving the one signal they need before the weight ever touches his hands. And once you understand what that signal is, everything about training after 60 starts to make sense, and everything about why so many older lifters work incredibly hard for nothing finally has an explanation. Before we go further, if you are over 50 and lifting weights without seeing the results you expect, this is exactly the kind of biology smart psychology exists to explain. So stick with this one all the way through, because by the end you will know precisely what your body has been waiting for, and you will know exactly what to change tomorrow morning before you ever pick up a weight. Let me start with the biology that almost nobody explains properly, something researchers call anabolic resistance. Muscle protein synthesis is the process your body uses to repair and build muscle tissue after it has been stressed by resistance training. In a young adult, that process responds fast and strong to a training session. The muscle fibers that were damaged during the lift send out signals, amino acids get pulled toward the site, and new muscle protein gets built at a rate that clearly outpaces breakdown. In a person past 60, the exact same workout, the same intensity, the same effort, produces a muscle protein synthesis response that is measurably blunted, sometimes by 30%, sometimes closer to 50%, depending on the study and the muscle group involved. This is not weakness of character, it is not a lack of discipline, it is a documented shift in cellular sensitivity that happens with age, and researchers like Elena Volpe at the University of Texas Medical Branch have spent decades measuring exactly how it works. Here is the part that most fitness content skips entirely. Anabolic resistance does not mean your muscles have lost the ability to grow. It means the threshold required to trigger growth has moved higher. Think about it like a smoke detector that used to go off with a small wisp of smoke and now requires a genuine plume before it reacts. The alarm still works, the wiring is still intact, but the sensitivity has changed, and if you keep producing the same small wisp of smoke you did at 30, the detector at 63 simply will not fire. Most older lifters are training exactly the way they trained decades earlier, with the same protein habits, the same pre-workout routine, the same assumptions about what their body needs, and they are essentially producing a wisp of smoke and waiting for an alarm that requires a plume. So what actually raises that alarm? This is where the leucine threshold comes in, and it is the single most important piece of biology in this entire video. Leucine is a branched-chain amino acid, and it acts as the primary molecular trigger for a pathway inside your muscle cells called mTOR, mechanistic target of rapamycin, which is essentially the master switch that turns on muscle protein synthesis. In a younger adult, roughly 1.5 to 2 grams of leucine, delivered through around 20 grams of high-quality protein, is enough to flip that switch and start the building process. Research from Douglas Patton Jones and his colleagues, along with work from Stuart Phillips at McMaster University, has repeatedly shown that in adults over 60, that same 20-gram dose barely moves the needle. The muscle protein synthesis response looks almost flat, but when researchers gave older adults a larger dose, somewhere around 35 to 40 grams of protein, containing close to 3 grams of leucine, the muscle protein synthesis response in older muscle rose to match, and in some studies nearly equal, the response seen in younger adults given the smaller dose. The muscle was not incapable of responding, it simply needed a stronger signal to cross its higher threshold. This is the missing piece for the man in the gym we started with. He lifts the weight, he goes home, he eats a normal meal with maybe 15 or 20 grams of protein scattered through the day, and he assumes the workout itself is the stimulus his muscle needs. But the workout is only half of the equation. Resistance training creates the mechanical damage, and the signaling cascade that makes muscle receptive to growth. It essentially opens a door, but without enough leucine crossing the threshold on the other side of that door, the building process that turns stimulus into actual tissue simply does not get switched on at full strength. He is doing the hard part, the actual lifting, and skipping the biochemical part that determines whether the hard part pays off. Now, let's talk about why this threshold rises in the first place. Because understanding the mechanism is what makes this stick instead of just becoming another rule you forget in a week. Part of it comes down to something called the splanchnic extraction of amino acids. When you eat protein, a portion of those amino acids gets absorbed and used by your gut and liver tissue before they ever reach your bloodstream and travel to your muscles. In older adults, this splanchnic extraction increases, meaning a larger share of any given protein dose gets intercepted before it reaches the muscle at all. Give a young adult 20 grams of protein, and a large share of those amino acids reach circulating blood and eventually muscle tissue. Give an older adult the same 20 grams, and a noticeably bigger portion is captured along the way, so the muscle simply never sees a strong enough leucine spike to cross its threshold, even though the same amount of protein was technically consumed. There is also a receptor sensitivity piece worth understanding, because it explains why two people eating the exact same meal can get very different results from their muscle tissue. Vitamin D receptors exist directly on skeletal muscle fibers, and vitamin D appears to play a role in how efficiently muscle tissue responds to a protein and training stimulus. A large percentage of older adults run low in vitamin D, partly due to reduced skin synthesis with age and partly due to less time spent outdoors, and researchers, including Alfonso Cruz-Gentoft, who has published extensively on sarcopenia, have pointed to low vitamin D status as one of several modifiable factors that appear to worsen anabolic resistance in aging muscle. This does not mean vitamin D alone builds muscle. It means an older adult who is deficient may be adding another layer of resistance on top of the leucine threshold problem, and correcting a genuine deficiency, ideally confirmed through blood testing with a physician, removes one more obstacle, standing between the protein you eat and the muscle you are trying to build. There is a second contributing factor, and it involves blood flow. Younger muscle tissue responds to a meal with a measurable increase in blood flow to the limbs, which helps deliver amino acids efficiently to the muscle fibers that need them. This response, sometimes called nutrient-induced vasodilation, appears to weaken with age, partly due to changes in the lining of blood vessels called the endothelium. Researchers including Benjamin Miller and Karen Hamilton have documented age-related declines in vascular responsiveness that directly affect how efficiently nutrients get delivered to working muscle. So you have two compounding problems happening simultaneously: more amino acids getting diverted before they ever reach the muscle, and less efficient delivery of whatever amino acids do make it into the bloodstream. Both problems point toward the same practical solution. A larger and more concentrated leucine dose is required to overcome the losses at every stage of the journey. This is also where satellite cells enter the picture, and they deserve real attention because they are one of the most fascinating parts of muscle biology. Satellite cells are a population of stem cells sitting on the outer edge of your muscle fibers, essentially dormant, until they receive a strong enough signal to activate. When they activate, they can fuse with existing muscle fibers, donating their nucleus and effectively expanding the fiber's capacity to produce new muscle protein. In younger muscle, satellite cells activate readily in response to resistance training. Research from Gianni Parise and colleagues at McMaster University has shown that in older adults, the satellite cell response to a single bout of resistance training is often reduced, sometimes described as a blunted or delayed activation. But here is the encouraging part of that same body of research. Satellite cell activity in older muscle is not permanently impaired. It responds strongly to consistent training combined with adequate protein intake. And over weeks of proper stimulus, satellite cell pools in trained older adults begin to resemble those of much younger sedentary individuals. The system is trainable. It simply needs the right combination of mechanical stimulus and nutritional signal to wake back up. If you are finding this useful, this is the kind of research-based breakdown smart psychology puts out regularly. So if training after 60 or supporting someone you love through this stage of life matters to you, sticking around for the rest of this video is going to give you the complete practical picture, not just the biology behind it. Let's talk about testosterone and growth hormone, because they are part of this story too, though probably not in the way most people assume. Testosterone declines gradually after roughly age 30, at a rate of around 1 to 2% per year in most men, and growth hormone secretion also declines with age, a pattern sometimes called somatopause. Both hormones play a genuine role in muscle protein synthesis and recovery. But here is what the research actually shows, and it often surprises people. The decline in these hormones, while real, explains only a modest portion of the reduced muscle-building response in older adults. Multiple studies comparing hormone levels directly against muscle protein synthesis rates have found that the anabolic resistance we already discussed, the blunted response tied to leucine sensitivity, splanchnic extraction, and blood flow, accounts for a much larger share of the problem than hormone decline alone. This matters because it means the solution is not necessarily hormone replacement, which carries real risks and should only ever be discussed with a physician. The solution is largely available through training and nutrition strategy, which is something every person reading this can act on directly, starting with the very next meal they eat. There is also myostatin to consider. Myostatin is a protein that acts as a natural brake on muscle growth, limiting how much muscle tissue your body builds and maintains. Some research suggests myostatin activity may increase somewhat with age and with physical inactivity, which would mean the brake gets pressed down harder exactly when you need it pressed down less. The encouraging finding across multiple studies is that resistance training itself appears to reduce myostatin expression over time, meaning consistent lifting does not just build muscle directly, it also appears to loosen the very brake that was making growth harder to achieve in the first place. This is one more reason why stopping training after a discouraging few months is exactly the wrong response, because the biological environment inside your muscle tissue continues shifting in your favor the longer you stay consistent, even when the mirror is slow to show it. So now let's put the biology into an actual practical protocol, because understanding the mechanism only matters if it changes what you do tomorrow morning. The single most important adjustment is timing a substantial leucine-rich protein dose in the window before your training session, roughly 30 to 60 minutes beforehand. We are talking about 35 to 40 grams of high-quality protein, something like 3 whole eggs with a serving of Greek yogurt or a whey protein shake mixed with milk, or a combination of cottage cheese and a scoop of protein powder. The goal is reaching that higher leucine threshold your muscle tissue now requires, roughly 3 grams of leucine, before the mechanical stimulus of lifting even begins, so that by the time you are under the bar or holding the dumbbells, your muscle tissue already has the biochemical raw material and the trigger signals circulating and ready to be used the moment training creates the demand. This single change addresses the anabolic resistance problem directly at its source. Instead of asking a blunted, less sensitive system to respond to the same small protein dose that worked decades ago, you are deliberately overshooting the threshold, accounting for the increased splanchnic extraction and the reduced delivery efficiency we discussed earlier, so that enough leucine actually reaches the muscle to flip the mTOR switch. Many older lifters who make this one change, without altering their training program at all, report noticeably better recovery within 2 to 3 weeks, and measurable strength and size improvements show up over the following months in a way their previous routine never produced. The second piece, and this is where neuromuscular activation comes in, involves what happens in the minutes immediately before your working sets. As we age, the connection between your nervous system and your muscle fibers, called the neuromuscular junction, becomes somewhat less efficient at recruiting the largest, fastest twitch muscle fibers, the ones most responsible for size and strength gains. Research on motor unit remodeling, including work by John Faulkner and colleagues studying aging skeletal muscle, has documented this shift toward less efficient fiber recruitment over time. A proper warm-up that includes several progressively heavier ramp-up sets before your actual working weight does more than protect your joints. It primes the nervous system, improving the recruitment of exactly the muscle fibers you need firing in order for the leucine and mTOR signaling you just set up to actually translate into meaningful tension and growth stimulus. Skipping the warm-up and going straight to a working weight, something many time-pressed older lifters do out of habit, means asking a less efficient recruitment system to perform at full capacity cold, which reduces the quality of the stimulus your muscle fibers actually receive. Joint and tendon health deserves mention here too, because tendons stiffen somewhat with age, and connective tissue takes longer to warm up and become pliable compared to muscle tissue itself. A 5 to 10 minute period of light cardiovascular movement, followed by dynamic mobility work, targeting the specific joints you will be training. That day allows tendons and connective tissue to reach a more elastic, more resilient state before they are asked to transmit real load. This is not just about avoiding injury, though that matters enormously, because an injury at 60 can sideline training for months in a way it never would have at 30. It is also about allowing force to transfer efficiently from muscle through tendon into the actual movement, so the mechanical stimulus your muscle fibers experience during the lift is as complete and effective as possible. Putting the entire sequence together looks like this. Roughly 45 minutes before training, you eat a protein dose in the 35 to 40 gram range, built around a high leucine source like eggs, dairy, or whey. In the 10 minutes before your working sets, you move through light cardiovascular activity and dynamic mobility targeting the muscles and joints you are about to train, followed by 2 or 3 progressively heavier ramp-up sets that prepare your nervous system to recruit the fibers that matter most. Only then do you move into your actual working sets, at which point your muscle tissue has the biochemical trigger circulating, the nervous system primed for efficient recruitment, and the connective tissue ready to transmit load safely. This is the sequence that closes the gap anabolic resistance created, and it is almost entirely free. It requires no supplements beyond food you likely already have in your kitchen, and it requires perhaps 15 extra minutes built into a routine most people already have. After training, the same leucine threshold principle applies again. Consuming another 30 to 40 grams of protein within roughly 2 hours after your session extends the elevated muscle protein synthesis window that resistance training creates. Research from Tyler Churchward-Venay and Stuart Phillips has shown that spreading protein intake across 3 to 4 meals daily, each crossing that higher leucine threshold, produces meaningfully greater 24-hour muscle protein synthesis in older adults compared to the more typical pattern of skipping protein at breakfast and loading it all into dinner. Most older adults eat something like 10 grams of protein at breakfast, 20 at lunch, and 60 at dinner, and that dinner dose is largely wasted from a muscle-building standpoint, because your body cannot meaningfully use protein far beyond what a single meal's muscle protein synthesis machinery can process at once. Distributing that same total protein evenly across the day, with particular attention to the pre- and post-training windows, gets dramatically more value out of the exact same food. One supplement worth mentioning here, because the research behind it is unusually strong for a population this age, is creatine monohydrate. Creatine helps regenerate the primary energy currency your muscle cells use during resistance training, and a substantial body of research, including work reviewed by Darren Kandow at the University of Regina, has shown that creatine supplementation combined with resistance training produces greater gains in muscle mass and strength in older adults compared to resistance training alone. Typical protocols use around 3 to 5 grams daily, taken consistently rather than timed precisely around training, and the safety profile in healthy older adults has been studied extensively without evidence of the kidney or liver concerns some people worry about, though anyone with existing kidney disease should still confirm safety with their physician first. Creatine will not replace the protein timing strategy we just walked through, but layered on top of it, the two appear to work through complementary pathways, one supporting the energy demands of the training session itself, and the other supporting the biochemical trigger for building new tissue afterward. It is worth being honest about something else too, because most videos in this space skip it entirely. None of this works without the actual mechanical stimulus of resistance training performed consistently over months and years. Protein timing and leucine thresholds and warm-up protocols are optimizing a system that only responds because you are showing up and applying real progressive load to your muscles in the first place. A person who nails every detail of nutrition timing, but trains with the same light dumbbells for years without ever adding weight or effort will still see minimal results, because the mechanical signal opening that door we talked about earlier has to actually be strong enough to matter. Progressive overload, meaning a gradual, consistent increase in the demand you place on your muscles over time, remains the foundation everything else in this video is built on top of. There is a broader point worth sitting with here, because sarcopenia, the age-related loss of muscle mass and strength, is not a cosmetic issue, It is one of the strongest predictors of falls, fractures, loss of independence, and mortality risk in older adults. And researchers studying this decline consistently find that the people who maintain muscle mass into their 70s and 80s are not simply genetically fortunate, they are almost always people who kept training consistently and kept feeding that training properly. The man from the beginning of this video was not failing because his body had given up on him. He was failing because nobody had ever explained that his muscle tissue needed a stronger signal than it used to, delivered at a more specific moment, in order to respond the way it once did automatically. If this changed how you think about training after 60, or if you know someone who has been quietly working hard in the gym without the results they deserve, sending them this video might be the most useful thing you do for them today. And if you want more research-grounded breakdowns like this one, Smart Psychology puts these out regularly, so subscribing means you will not miss the next one. Your muscle tissue at 63 is not the muscle tissue of a person who has stopped being capable of growth. It is the muscle tissue of a person whose threshold moved. And now you know exactly what it takes to cross it, starting with the very next meal you eat, before you ever pick up a weight again.